All right, let's jump right into this explainer. Today, we're going to connect massive, highly unpredictable global geopolitical shifts to, well, the literal walls of our homes. I know, it sounds like a pretty massive leap, right? But stick with me here, because by the time we wrap up, you're going to see exactly how the macroeconomics of the world stage completely dictate the microenvironment of your own living room.
We're going to look at how our extreme vulnerability to global oil supply shocks actually contrasts with a really brilliant, incredibly localized architectural solution. I mean, we spend so much time doom scrolling, right? Worrying about conflicts happening halfway across the world. But as it turns out, the ultimate defense against that kind of global instability might just be the way we design the very buildings we sleep in.
Section 1. The vulnerability of oil.
To really understand the localized solution we're heading towards, we first have to establish the stakes of our global energy dependence. And to do that, we need to rewind a few decades. Let's look at 1970. That was the year petroleum production in the United States hit its absolute peak. With domestic wells maxed out and other major producers peaking around the exact same time, the West was suddenly forced to rely heavily on foreign suppliers for the absolute most crucial resource in their entire economy. Control of the oil supply suddenly morphed from a manageable domestic commodity into a highly dangerous international vulnerability.
Which brings us to Section 2, the 1970s energy shocks.
This growing dependence set the stage for a decade of intense geopolitical volatility. And it's actually wild to look at how quickly the dominoes fell here. We go from domestic production peaking in 1970, straight into the 1973 Yom Kippur War. OPEC countries retaliate with a harsh embargo on oil exports to the U.S. Boom! Suddenly, real and perceived supply shortages create a massive shock to everyday citizens. And just as things felt like they might be stabilizing, the decade culminated with the 1979 Iranian Revolution. Widespread protests completely shattered the local oil sector there, sparking a global panic that drove prices astronomically high.
Section 3. The economic fallout.
As you can imagine, these supply interruptions sent absolute shockwaves through the major industrial centers of the world. The era of cheap, reliable energy was essentially dead. Between 1978 and 1980 alone, the price of West Texas Intermediate crude oil increased by a staggering 250%. I really want you to stop and imagine that for a second. Imagine the cost of the fundamental fuel that runs your entire life, your heating, your commuting, getting your groceries to the store, more than tripling in just a 2-year window.
This unprecedented combination of soaring oil prices and a sputtering economy led economists to coin a grim new term, stagflation. It's exactly what it sounds like. It was a period of severe economic contraction mixed with high inflation, causing real human misery. Factories slowed down, costs skyrocketed, and by May of 1975, U.S. unemployment peaked at a really painful 9%. Basically, the entire world was learning a very hard, very expensive lesson. Relying on volatile, centralized energy systems is a massive liability.
So, with entire economies essentially held hostage by foreign supply and price shocks, we really have to ask ourselves, how can we project ourselves at the most fundamental level? If we can't control the geopolitical conflicts of the world, how do we just opt out of this volatile system entirely?
Let's look at Section 4. What is passive design? This brings us to a surprisingly simple, localized antidote to all this global energy chaos. It's an architectural approach that completely rethinks our relationship with consumption. By harnessing natural climatic effects, we can drastically reduce our energy demand. Think about it this way. Instead of constantly pumping a drafty house full of expensive, volatile fossil fuels just to fight off the winter chill, what if the house itself acted like a thermos, trapping the heat that was already inside?
And perhaps the best part, these highly efficient homes don't have to look like windowless space-age concrete bunkers. They are stunning, modern spaces that blend right into a normal neighborhood. Looking at a beautiful, traditional-looking home built this way, you would literally never guess it operates on a sheer fraction of the energy of the regular house right next door to it.
So how does it actually work? Well, instead of massive furnaces and complex ductwork, these homes rely on 4 strict, pretty common-sense strategies. First, you heavily insulate the building, basically wrapping it in a thick winter coat with minimal thermal bridges where heat can sneak out. Second, you strategically harness the sun, plus the internal heat of your own appliances and body heat. Third, you make the building envelope practically airtight so random drafts can't steal your warmth. And finally, because it is so airtight, you use a heat recovery ventilation system to ensure pristine indoor air quality. It basically acts as the fresh air lungs of the house. It's elegant, it's simple, and it's incredibly effective.
Section 5.
harnessing the natural elements. Let's zoom in on that second strategy for a second, solar gain, because it builds upon the greatest, most abundant free energy source we have. Prepare to have your mind blown a little bit here. Every single year, the sun supplies nearly 36,000 times the amount of energy currently provided by total world oil consumption. 36,000! It acts like a massive fusion furnace, radiating free energy to us 24 hours a day, 365 days a year, with absolutely zero geopolitical strings attached to it.
So how do we actually catch that energy? It's just simple physics. By deliberately designing windows and angles to allow visible light, infrared and ultraviolet radiation to strike the materials inside a home, that radiation is absorbed. The floors and walls naturally convert it into free heat energy. You are essentially turning your living room into a giant thermal battery that charges up just by opening the curtains and letting the daylight pour in.
Section 6. Building Energy Independence.
Let's look at exactly what happens when you combine that free solar heat with extreme airtight insulation. This is where the macro world really meets your microenvironment. To qualify for the strict Passive House standard, a home caps its heating energy input at just 15 kilowatt-hours per square meter per year. Okay, so what does that technical jargon actually mean for you? It means it uses about 1/10 of the energy demanded by a typical new Canadian house. You are slashing your heating and cooling demand by a jaw-dropping 90%.
By adopting this standard, a single home essentially bypasses those volatile global energy markets entirely. A passive house saves the equivalent of 300 liters of oil every single year compared to a standard build. Think back to those 1970s energy shocks and that painful stagflation we discussed earlier. When your home barely requires any oil or gas to stay perfectly warm, an embargo or a sudden price spike halfway across the globe simply doesn't hold your personal economy hostage anymore. You are insulated, literally and economically.
And the coolest part is, this isn't some utopian science fiction pipe dream. It's happening right now. Entire municipalities, like the city of Vancouver, are already utilizing this exact toolkit with a massive goal in mind, ensuring all new construction is greenhouse gas neutral by 2030. Planners and architects have realized that localized, aggressive action, rethinking our literal walls and windows, is the ultimate shield against global instability and future climate challenges.
This whole journey leaves us with a pretty profound realization about our own agency. We don't have to just be victims to the boom and bust cycles of global energy cartels. So I'll leave you with this. If the blueprint to opt out of global energy shocks is already written into the walls of passive homes, what is stopping us from rethinking every single building we live and work in? It's a fascinating question, for sure, and one we absolutely must carry forward into the future of how we design our world. Thanks for diving into this explainer with me.